All right, welcome. We're starting with Ags3. This is module 1.1, and it's called Brutus Bites Back. Really, though, it's about inverses or inverse functions. All right, and so they set up a scenario for dog food, and there is a company that sells 7 pounds of dog food for $5. And so Carlos went ahead and graphed this, right? And so the question is, what's an equation for the function? And I'm going to use D for the dollars. This is D. And I'm going to use P for pounds. So pounds. So dollars is based on pounds. So in my equation, it should be D of P is equal to something. On this one, I would use slope-intercept, and I noticed that the slope goes up 4, or I'm sorry, 5, and then it goes over 7. So the change in y over the change of x is 5/7. Okay, and I'm going to multiply that times the independent variable, which is p. Here's another one. Same scenario, but notice instead of dollars and pounds, this one is reversed, pounds and dollars. Okay, so to come up with an equation here, and this, by the way, is at 5/7, using D and P also, I can say that pound is a function of dollars. My slope is going to be up 7 over 5. So it should be 7D over 5 using my slope-intercept. They start at 0, 0. So write a question for Carlos' graph. Carlos' graph is how much money for pounds, however many pounds we have. So dollars as a function of pounds. The Claritas is how many pounds for however many dollars. Okay, you see how it's reversed. What is the relationship? Well, we saw that with 1 point. Over here, we had 7, 5. Okay, so if we had 7, 5, and then on the other one, we had 5, 7. So this is a fundamental thing with inverses, is that the x and y switch for all inverse functions. Okay, and then I want to call your attention to notation. This -1 up here, it doesn't mean it's to the negative first power. Like, it's not the same as 2 to the negative 1 is equal to 1/2. That's not what they're talking about here. This is a different meaning, and this is to say that it's an inverse function. And if you have the function p of d, its inverse could be either d to the negative 1 or d of p to the negative 1. I've seen both of these here. Okay, same thing, if you have d of p, the inverse would be p to the negative 1 or p to the negative 1 of d. These are common ways of writing this, right? And so then they say, well, what about this one? If it's 8 pounds for $6, but you get a $5 shipping fee, what would it be? So in terms of dollars, you've got that $5 plus for every 8, for every $6, you have 8 pounds. Change in y over change in x. So your equation is 6/8, and we might as well make this 3/4 plus 5, right? And that's what that would look like. And that matches here because the slope is up 3 and over 4. 4/8 is on the graph. Now to do the other one, it's P of D. So to do this, what I would do is say D equals 3p over 4 plus 5. I'm going to solve my equation for p. And so I've got D minus 5 is equal to 3p over 4. Okay, and let me come over here and finish that. So then I'm going to say 3p is equal to 4 times d minus 5. And so p is equal to 4/3 times d minus 5. So p of d is 4/3 times d minus 5. Okay, and with this equation, if d is equal to 5, I can see that 5 minus 5 is 0, so p of 5 is equal to 0, and that is my point at 5, 0 when p is equal to 5. Okay, there's some cool stuff here too, like if you were to copy, paste, and slide it, you would notice things like, whoa, that's actually symmetric. Get this lined up properly. That's actually symmetric to, around the line y equals x. So that's kind of cool. Some cool stuff there. All right, and use function notation to write the relationship between the functions. So p inverse is the same as d of p. D inverse is the same as p of d. One's the input, one's the output.